project is called Cleanse, and you'll notice that we spell it a little bit differently, and that is completely intentional. Cleanse is just a play on the word lens, because what we're doing is we're using a lens to take a photo of a water sample, and then we're going to use machine learning and computer vision to detect moving particles and ultimately reach a conclusion about whether or not the water would be safe or is relatively still.
So we will now start the application. There's going to be a lot of stuff happening here. It takes like 10 minutes each, 10 seconds each time, right? So a bit about the application. So Yash mentioned that we use neural networks. A bit more on that.
So I know you guys can't really see it all that well, but we have a little contraption here. And basically it's an Arduino connected to a light. And then we have a spot for our tube to go. We 3D printed the outer casings, and then we wrapped it in electrical tape for grip and for sturdiness. And essentially on one side we have a piece of like white paper, which is actually just a bunch of index cards. But when the light shines on it, it creates a white background. Because when we're comparing the images, we want to ensure that we have some consistency as to what's going on in the background so that we can really get accurate results.
So we're going to do a test on a clean tube of water. It's really simple. I just put in the tube in the device and I click update. This is going to take a photo of the tube. So as you can see, since the tube is clear, we're just going to get a white picture. So right here, I can click perform single classification, and it's going to tell me what it thinks about the tube. Now, here we have a section called one-time test results. As you can see, there are no particles there, so we can't really extrapolate anything from there, but we can tell that it thinks that the water is good. So let's say we have a bad sample of water. Yeah, right? So, can you hold that up? So say we put that in, right? It's that simple. Slides are in. And then you click update, and then you can see, wait, no, I'm good, wait.
So it's binary, right?
Give it a second. Oh, it's the light. The light broke.
Oh, there you go. We have some light now.
No, it's on, wait. No, it works. Okay. I was wrong. Sorry. So, wait, no, this is not. I'm sorry.
Alright, so as you can see, we have a lot of samples of bad water. This one's like yellowish, it has like brown particles floating in it. And we're going to put this
in, and I'm going to click update. There we go, that works. So that's a bad sample of water, and I can again click perform single classification, and as you can see, it says that the water is bad. And we can also see data from the particles that it detects in the water. We can see that we found 17 analyzed particles, and we found that the average size of each particle is 0.06 centimeters, right? And we also found the average solute per 1 milliliter of solution, right? So a bit more about how we actually detect this. There are two types of machine learning going on. The first one is a convolutional neural network. It has 2 hidden layers, 500 units each, I think. And this neural network is actually really good. We had a training set of about 20,000 examples and a validation set of about 20,000 examples, and it has 100% accuracy on both of those, which is an overfitting in my opinion. Yeah, okay.
So the batch test results is actually going to be a string of photographs, and then we're going to analyze them and then compare the change in them over time. As you can see, you'll see the total particle count, and you'll be able to compare that to the particle count in your first image, as well as you'll see the trend. And if the trend is negative, that means the particles are settling. That's a good thing. You want the water to settle so that when you do take the water that's in the middle, the water that we're looking at, it'll be clear.
It's going to look like it's breaking. It actually works.
So in this case, because we flipped it upside down and then we flipped it back, we have large particles coming from the top to the bottom, and that's why the particle size trend is positive.
all of the images that we got while the particles were moving. We got 96 total particles, and we also have a slightly better volume of all the particles. That's a thing, I guess. Yeah.
So just to give you guys a kind of clearer picture about what our vision is really our concept at its core, and that's that you can take a photo of water and you can understand the water and you can get a sense of how clean it is using just one thing, and that's a camera. So yes, we did have a little bit of hardware, we did have to create that kind of white background, but ultimately as we progress further, we want to look to using just one camera in order to get image and water quality so that we don't need to have specialists. The average Joe can just go out and understand the water that they have nearby. So looking for this project in particular, we're going to look towards creating different types of cameras. Right now we're using a webcam, so we would potentially look into using mobile cameras and things of that nature. And we also want to make sure that it works no matter what, and it doesn't need to go into our tube, as we said. So thank you. Are there any questions? Because when you take a video at a high FPS, then because we trained it using videos and then we're using photos in our actual thing.
Basically, you take the videos, you decompose them into photos, and we run image augmentation
yeah.
on them, and then we get a lot of training. It's like more than enough.
Would this be more accessible than just having sensors? Like,
Can you say that a little bit louder?
would it be more accessible than if you had like sensors detecting certain things in the water?
Well, actually, no. That would make it less accessible because, as you mentioned before, our final goal is just having this work with only a webcam.
Because at the end of the day, the goal is to have just the camera, because everybody has a camera. Every single one of you has a camera on your person. No, I'm willing to guess that none of you have a sensor to detect what's in the water on your person right now.
Like with some of the samples, you can obviously tell at a glance that I should not be drinking this.
Right.
How is your program like better than just looking at water stick?
Okay, so the question was, what makes our program better than just eyeballing a container of water and deciding whether or not it's bad or good? And the reason is that there can be like false positives. For example, you look at something like green tea. You put green tea in, what it's actually doing is it's putting particles in. That water still looks relatively clear. You would still drink that water. If you go to a pond, people who own ponds, they put alum in their water in order to change the pH because there are like, there's a lot of like chemistry behind it, but basically they want the particles to lump together and dissipate out of the solution. So a lot of times it's not as visible as it might seem.